G'day, it's James here. Welcome to the channel, videos about home automation and installation. Today I have a video for you about this little device right here. This is a leading edge, trailing edge dimmer, single channel Wi-Fi designed to integrate easily into Home Assistant with fully easy to customize and set up to your specifications. And it works really well. Obviously the purpose behind this dimmer is not to replace puck in-wall dimmers, but rather it's to give an alternative if you're renovating or building a new house. These can be mounted in a switchboard enclosure. You pass them on to your electrician and it will come in single channel, 2 channel, 4 channel or 8 channel. And it's designed to easily and cheaply integrate lots of dimmers into your home to connect up to Home Assistant. But before I got to this version, there was a few other versions that I went through. So this was the first version, and this was actually connected to an ESP32, and I used the onboard DAC on the ESP32 to control it, and this version worked. It worked quite well. The second version also worked. On this one I used an op-amp, a dual channel op-amp to control a 2-channel dimmer. Now this sort of worked. One channel worked on its own, but they wouldn't work together. It wouldn't, it just wouldn't work together. So there's still more work to do on the multi-channel versions. After that version we had this one, and this one did work. However, I discovered an issue with this dimmer controller, and that is the power supply runs on a shunt power supply through a resistor, and the resistor that powers it gets very hot, and apparently that's the normal way for it to run, and I didn't like that, so I tried to make a better power supply for the dimmer. So I tried to, this is the next version, and I tried to use a non-isolated power supply to power the dimmer, and it didn't work. I made another attempt at it, and that one didn't work either. And that's led me to this one here that I have for you today, which works perfectly. I'll show you where you might install this dimmer. Bearing in mind, it's not designed to replace the in-wall puck type ones. Obviously the need arose is in Australia we have very, very hot roof spaces and often have little room in switch boxes to install a puck style dimmer. So the idea is this goes in a wiring enclosure where it's cooler and more protected, and they're all centrally located. So obviously that would extend the life of the dimmer itself and make it easy to set up a whole row of dimmers or circuits going out to the lights in your house. So the idea is this dimmer would go inside a wiring enclosure like this, which is very common in Australia and also in many other parts of the world. It's a DIN rail enclosure designed for electrical equipment, and this is the dimmer here inside its case that it fits. If I just remove the cover from the switchboard, so that's this dimmer that we're looking at today, and that's the case that it comes in. And as you see, it can mount on the DIN rail just here, and you can bring the wiring into the bottom, and it can you can have a number of channels and it can go out to the rest of the house. Obviously the idea is that as the channels increase inside the modules, it will take up less space, and hence you'll hopefully be able to fit in a, this is an 18 pole enclosure, you'll be able to fit 2 8-channel dimmers in here, so 16 circuits if you wanted to, inside an enclosure this big, and it could head out to all your lighting circuits that need dimming. Okay, so this is the dimmer here. Now, as we noted, this is designed to go in a generic DIN rail enclosure, and in that enclosure it takes up 2 modules of a wiring enclosure. Now, the first thing I like to note is the terminals here is a cage style terminal. That makes for secure connections. It can fit quite a large wire diameter in there, and it has the little returns underneath that stop you from pushing the cable in under the terminal, and that will prevent getting any loose wires. It has here a 1 amp fuse just to protect from overload, and it has a filter capacitor to filter out any EMI. The only thing that's missing from this version here that it does need to have is a
an inductor to filter out the EMI as well. So it needs an inductor as well, a common mode inductor. It has the power supply, which is a 12 volt DC power supply, 2 watts, and it also follows up with a 3.3 switching power supply down here to power the ESP module and the DAC over there. So these can be either MOSFETs or IGBTs. These are IGBTs, and they are protected by these MOVs from excessive voltage. These are rated at 600 volts, and they're controlled by this IC here, which is an FL5150, which is the 50 Hertz version. There's also an FL5160, which is the 60 Hertz version for the US. And it has the gate driver through here that turns these on simultaneously. They are in series, which means that on the upside of the sine wave on the AC, when they're turned on, it'll pass through one, and then it will pass through the bypass diode on the other. And then when the AC goes into the negative side, it will pass through the other one, and then it will pass through the bypass diode on the other one, unless it's turned off, in which case it won't pass through at all. So because it's got the two, it's able to control leading edge and trailing edge, whichever you choose. Now that can be selected with this this pin here. At the moment it's in trailing edge, but you can just swap it over to leading edge if you wanted to. And that goes in to the IC just here. Now the IC controls all the zero crossing and the timing for us, so we don't even have to worry about that. It's got the zero crossing is measured through this resistor just here off the neutral conductor. The only thing we need to do is control an analog voltage up to 2.6 volts to set the dim level, and that is done by this little DAC just here. And this little DAC is an I2C DAC, and so that's controlled by this ESP8285 module just here. And on this module I have got loaded ESP Home, which I use with Home Assistant, and it works pretty well, and there's a lot of settings you can set to adjust how the dimmer operates. Obviously you could use anything that can run on an ESP8266, including using the Arduino IDE to run a program. As long as you can control that DAC just there, then you can control this dimmer. So that's the dimmer. So now we're just going to plug it in and we'll try it out. We'll see the range of dimming that it has, and we'll check out briefly the setup we've got in Home Assistant and how we can control it in Home Assistant, and also with an encoder or a potentiometer, so we can have that at a wall switch and we can control it that way as well. Or I've actually just got this set up to a Wemos D1 Mini and a potentiometer, and it's just using the ADC function in Home ESP, and you could remotely locate this at a switch plate to control the lights, and that's what I'm going to be using to control the lights now in the video. I'm just going to be using this little potentiometer to wind the lights up and down. Now I've got these downlights set up here just so we can demo it, and as you can see I've just got this prop here that we can light up, and we can see the lights in action and see the range that they have. And we've just got our dimmer that's plugged in safely way over there. So we're going to use Home ESP and Home Assistant to control it, and we've got our controller just here. Okay, so we're all set up, and now we can try out this dimmer. So we're at full brightness right now, and we're just going to slowly dim down to right down to off. And now we've got our dimmer off, and we can bring it back up again and turn it on up to full brightness again. And we can also just control it through Home Assistant. like so. So now I'll just jump across and show you the Home ESP code. So we've got the little dimmer controller, which is just here. So we've got an ADC set up just here, which the potentiometer is running on. Then we've got an automation that accesses Home Assistant and sends a service to turn the light on. And this light here is our dimmer, which is also set up as another node on Home ESP. And I found that I had to use a data template to get it to work. And it has to be, one of the reasons is that the brightness percentage has to be passed to Home Assistant as an integer. And the sensor outputs float values. So you can't send that into here. It won't work unless you convert it into an integer first. So that's the dimmer controller, and we'll have a look at the DIN-rail dimmer. So it's got a custom file that's included just here, the header file, and it's got the I2C set up to access the DAC, and this output component uses the custom header file to access the setting the DAC to the required voltage level, and then that output is used within this light component. And that is what Home Assistant gets to turn the light up and down. And if we come across into Visual Studio, we can check out the code for the header file. So this is the code here, which I pieced together from bits and pieces that I found all over the internet. Basically, it uses wire write to the DAC on I2C. And basically, first of all, if it's off, it writes off. If it's any value other than off, it writes a value from. It writes the value, but this is where we can adjust exactly how we want it to work, because different lights will need different values. So we've got the lower value just here, and the higher value just here. So if we want the dimmer to go higher, we can adjust that up. If we want the dimmer to go lower, we can adjust that here. Because we've got that set perfectly for these lights, you'll see that when we're on 1%, the lights are on pretty much at their perfect level. And then obviously at 100%, you've got full power. So each, depending on the lights, you can adjust that to suit. And you'll notice too that this map function has to reverse it because it's inverted via the DAC. The DAC inverts the values in this setup. And then, of course, once the value is calculated, it just writes the value to the DAC using I2C. So that's pretty simple, not much to it. And yeah, I've been using it for a while, and it works pretty well. And the dimmer itself runs really cool. It doesn't get hot. It runs at a comfortable 40, 45 degrees with that switch mode power supply. And yeah, it works really well. And the downlights will dim down to about 1 watt each. So if I've got 4 downlights on here at full power, they use 10.5 watts, and on a very low level, they'll just use 1 or even less than 1 watt each. So it's a good way to save power. It's a good way to have lots of dimmers in your house. And I guess this is just the start. And hopefully I'll work on the others, and I'll make some multi-channel ones, and I'll bring them out. Anyway, I'd like to thank you for watching, and I hope you stay tuned to see more updates on the dimmer project. And if you want to see more, make sure you subscribe, and make sure you get notified with the bell. And yeah, thanks for all the support, and thanks for watching. I'll see you next time.